Now let's set up a tree diagram for the partial of w with respect to t. We know we're going to get a partial here because our function, while it's a function of these three variables x, y, and z, those functions are then functions of two other variables throughout, s and t here. So we're actually getting a partial of w with respect to one variable s and the other variable t. I've just elected to work through the half where it's the partial with respect to t, but we'll set up the entire tree diagram anyway, just so we can see how all of these partial derivatives lay out. So it is a function of three variables initially. We'll need three branches for our setup. One to represent the partial with respect to each of those three variables, x, y, and z. So the first part of this then is going to be the partial of w with respect to the x variable. Then we have the partial of w with respect to the y variable, and the partial of w with respect to the z variable. So this is the derivative of the outer functions. Of course, now we need to multiply by the derivative of the inner function. Again, those are two variables. So we have a partial with respect to s and a partial with respect to t all the way through those. So we'll need two branches on the end of each one of these partials, like this. And that'll give us all of our possibilities. So we took the partial here with respect to x on this upper branch. So now we'll take the derivative of the inner function there of x with respect to its two variables, and we would have the partial of x with respect to s and the partial of x with respect to t. And we work our way down the line. So here we took the partial of w with respect to y, I have the partial of y with respect to s, and I have a partial of y with respect to t. And for the last branch, I have the partial of z with respect to s and the partial of z with respect to t. So now we just multiply all of these up to get all the different partials. One branch will represent the overall partial of w with respect to t. The other one will represent the partial with respect to s. So let's lay those out. Here at the end of this, I have the partial of w with respect to x times the partial of x with respect to s. Here we have the partial of w with respect to x times the partial of x with respect to t. And just working our way down, partial of w with respect to y times the partial of y with respect to t, or s rather. Partial of w with respect to y times partial of y with respect to t. And on our last branch here, we have partial of w with respect to z times the partial of z with respect to s. And the last one, partial of w with respect to z times the partial of z with respect to t. Whew, okay, we made it. So now we've got to piece together the parts that we want. In this case, I asked specifically for the partial of w with respect to t. So we need to look at all those ones that have a t variable present in them. So that would be this, this, and this. We then add those three together, and we have partial of w with respect to t is going to be the partial of w with respect to x times partial of x with respect to t plus the partial of w with respect to y times partial of y with respect to t plus partial of w with respect to z times the partial of z with respect to t. So it's a long one, but there it is. And since I'm doing it, I might as well go ahead and put together the partial of w with respect to s. It's going to look basically the same. You have the partial of w with respect to x times the partial of x with respect to s plus the partial of w with respect to y times the partial of y with respect to s plus the partial of w with respect to z times the partial of z with respect to s. So you can start to see, when you write out these long ones, a bit of a pattern in terms of how we do it. Essentially, it's just a derivative of an outer function times the derivative of the inner function with respect to the variable that we want, and we just work our way down the list, x, y, and z, again multiplying by the appropriate partial derivative here as we throw on our chain rule piece. But that's essentially it. But again, the tree just kind of keeps us organized and on track, and to make sure that we don't miss anything.